Hey, welcome everybody. This is Mr. Gannon, and these are the 5.5 notes where we're going to look at solving systems of linear and quadratic equations. So earlier in the year, we did solve systems of linear equations, and we had three methods, which were graphing, substitution, and elimination. Those same methods will apply to these systems as well. So there is an exploration at the beginning of the notes for you. I've already filled out the tables to just make this video go a little bit quicker. But this is something you should understand how to do on your own by plugging in x values to the function to come up with the y values. But in this case, what the question is asking you to explore is use the table to find the x values where f of x is equal to g of x. So if we want to know when f of x is equal to g of x, we would look at our table and look at the y values. So over here, x is -3, y is 50, -3, 32. Those are different. But at -2, we have 29 here and 29 here. So here is a point where those two functions do have the same coordinates. All right. So x equals -2 would be a solution. The next time that happens is here and here. So when x is 3, both of these functions have a value of 14. All right, so based on the table, the x coordinates would be -2 and +3. And that is true for both functions. All right, now, it does say graph both equations on a graphing calculator. Well, if you don't have a graphing calculator, there is something that's available to everybody that's free on a device called Desmos. So if we were to pull up just any browser, and we can type in Desmos, D-O-S-M-O-S, graphing calculator. All right, this is a free calculator that we can use. So if we were to then take and graph those functions, so the first one is 3x squared minus 6x plus 5. So I can come over here. We're going to go 3x squared minus 5x. Make sure we do this correct. Oh, no, sorry, it's minus 6x plus 5. Screwed that up. All right, so we'll go back. Let's fix that. So minus 6x plus 5. All right, this is what that graph looks like. And then if I go ahead and graph the other function, which is -3x plus 23. All right, so we got -3x plus 23. All right, definitely not obvious what's happening here. But if I zoom out on the function, all right, we will see that these graphs are going to intersect each other at 2 points. One of the points is 314. The other point is -229. And if you go back and look at our table, all right, one of those places where the two functions were equal was -229, and the other was 314. So these solutions, all right, are the points where the graphs intersect. All right, so the solutions are the points where the graphs intersect. And that's something that's important to understand when we're solving systems, because we're going to be looking for the points where the functions intersect each other, and those become the solutions of our system. So that's kind of the key to this, this unit. All right, guys, taking a look at number 1. It says, first solve the system of equations by graphing on your calculator, then solve by using algebra. Now, I know it says to do this on a graphing calculator, but really we need to be able to graph these functions by hand. And if you go back to what we did in chapter 4, y equals -x squared plus 9, this has a reflection and shifted up 9. So if I know that, I can go ahead and from 0, 0, go up 9, put a point, and then because it's reflected, I go over 1, down 1 in both directions, over 2, down 4. Sorry, 1, 2, 3, 4 in both directions, over 3, down 9 in both directions. And I can graph this parabola without using a graphing calculator. Okay, and in this case, the way it's written, we should be able to do that. Now, if I look at y equals x plus 3, well, y equals x plus 3, that's a line. It has a slope of 1. Okay, so m equals 1, and the y-intercept is 3. So if you go back to kind of chapter 1, we begin at b, so we're going to go up 3 and put a point. We're going to move with our slope, which is up 1, right 1. All right, and you'll notice the graphs cross here. If I go down 1, left 1, the graphs are going to cross here. So those points where the graphs intersect here and here are going to be the solutions of our system. All right, so graphically, it looks like we have one solution at -3, 0, and the other solution at 2, 5. Now, in this example, neither one of those functions was extremely difficult to graph, and the solutions happen at whole numbers. So, graphing, if I have the ability to graph an accurate function, wasn't too bad. But most of the time, it's not going to be the most efficient method. So we want to end up solving using algebraic techniques. For me, when I'm solving linear systems, which is what we did earlier in the year, I'm usually going to use the elimination method. Definitely going to use it more often than not. But that's not always going to be true for these systems because it's not as easy to eliminate when you're dealing with a quadratic function and a linear function. So when I look at this problem, the first thing that I notice is that both equations are set equal to y. That to me is automatic substitution. So I can take this expression, x plus 3, and I can plug it into y right here. And that's going to be the substitution method. So let's see what happens when we do that. We get x plus 3 equals -x squared plus 9. What we need to recognize from here is that we have an equation that contains x and x squared, which is what we've been solving throughout this entire unit. So in this case, I'm always going to get the move everything to one side, making the x squared positive. So I would add x squared over to both sides, which would make x squared here plus x. I would subtract the 9 over, so 3 minus 9 is -6, and then that's going to equal 0. So that gives me an equation that I can now solve for x, and we're going to solve this by factoring. There's no GCF, 2 binomials, x squared is x and x. The negative would be plus minus. The factors of -6 that are going to combine to 1x are going to be +3 and -2. And what that does is that's going to give us solutions of -3 and +2 for x. So the thing you got to understand now is we're not done, because when we are solving systems, we are looking for ordered pairs or coordinates. By getting 2 different x values, that's going to tell us there are 2 different points. One of them has an x value of -3, and the other has an x value of 2. We're going to have to plug each of those into one of the equations above to find y. So this seems to be the easiest one. So if x is -3, then I'm going to write this as y of -3 becomes -3 plus 3, which is 0. So y of -3 is 0. That corresponds with -3, 0 as my coordinate. Whereas if x is 2, when I plug in 2, it's 2 plus 3. That gives me 5. So y of 2 is 5, which gives us the coordinate 2, 5. If we go back and look at the 2 answers we got graphically, -3, 0, and 2, 5 are exactly the same as these. So, that's just, again, showing us that the graphing method does work, and it helps us see that we're looking for those points of intersection, but it's rarely the most efficient method. So in this unit, we're really going to be focusing on either substitution or elimination. And if you have an equation that says y equals, that to me is when I would use substitution. All right, in the next example, example 2. All right, this is to me set up very similar. F of x and g of x are both different ways of saying y. So I'm going to go ahead and do the same thing we did and take this, plug it in here, which gives you the equation negative 3x minus 4 equals 4x squared plus 5x minus 4. Guys, I would suggest you pause the video and try to solve this on your own first, and then come back and watch it. All right, from here, when there's more than one term with a variable, I'm going to set it equal to 0. So I'm going to put the 0 on my left. The 4x squared is going to stay the same. We can add 3x to 5x to get 8x. And we can add 4 to negative 4 to get 0. All right. So then from here, when I go to factor this, I'm going to look for a GCF, which the GCF is going to be 4x. And then the other factor is x plus 2. Once it's factored, I can find my solutions for x, which from here would be 0, and here, negative 2. So I know that I'm going to have 2 points of intersection. One of them is 0. The other is negative 2 something. And what we have to do is plug into one of these equations to find those. So I'm going to use g of x. So if I do g of 0, then that's going to be negative 3 times 0 minus 4, which is 0 minus 4, or negative 4. So g of 0 equals negative 4. That means 0, negative 4 is a solution. I also am going to do g of negative 2. So this becomes negative 3 times negative 2 minus 4. Negative 3 times negative 2 is 6. 6 minus 4 is 2. So g of negative 2 is 2. And those become the solutions to the system. Okay. So there's an example where we did the substitution method using those systems. All right. Third example. Again, pause the video and see if you can do this on your own. You might have a little trouble, because if you look at it, this one's written differently. So if you need to, just continue watching the video. Now, I don't have an equation that says y equals or x equals right now. I could make that happen, all right? But if there is a time when I'm going to use the elimination method, this would be it. All right, and what I'm going to look at, though, is I want all of my variables on one side of the equation. So I've got x squared plus 14x plus 3y. This 1, I'm going to move over by subtracting it to make this 9. All right. Now, if I'm going to use the elimination method, the only variable that's going to be able to eliminate is the y. Because using 3x, there's no way to get rid of x squared. All right. So my only choice for elimination is to get rid of y. And if this equation has positive 3y, then I need to make this a negative 3y. So I'm going to multiply this equation by negative 3. And when I do that, I've got negative 9x minus 3y equals 15. Now we can add those two equations together, and we get x squared plus 5x equals, because the 3y's cancel, 24. To solve, I'm going to need to set it equal to 0. I'm going to subtract over the 24. All right, and then I know that this is something that I can factor. So x squared is x and x. Negative here means plus and minus. Now, factors of 24. If you make your list, it's 1 and 24, it's 2 and 12, it's 3 and 8, 4 and 6, and then 6 and 4 would be the next possibility, which means that's my exhaustive list. To get to 5x, I'm going to use the 8 and the 3. Positive 8, negative 3. Our solutions are x equals negative 8 and x equals positive 3. All right. So I know right now that my two answers are going to have these x coordinates, but I'm not done. we still need y. All right. And this is the part that can be a little bit tricky. I don't have an equation right now that just says y equals, but I can take this one and I can move the 3x to the other side. And when I do that, it will become y equals negative 3x minus 5. And again, all I've done is taken this equation and moved the 3x to the other side. So from there, I can plug in negative 8, which would become negative 3 times negative 8 minus 5. That's going to be positive 24 minus 5, which is 19. So negative 8, 19 is one of my solutions. I also need to do the same thing by plugging in positive 3. So I've got negative 3 times 3 minus 5. That's negative 9 minus 5, which gives me negative 14. So that's going to give us the coordinate 3, negative 14. And those are the solutions to that system. So, just kind of showing you that the elimination method can work, but it's really not always the best method for these types of systems. Okay? It has its place, but I would try to substitute first in these cases. All right. So now it says, what are the two algebraic ways to solve quadratic and linear functions? They are substitution and elimination. Those are the same algebraic methods that we had for linear systems. Okay. All right. Now, when we deal with these types of problems, it says how many answers will you get for these types of systems? Well, there's 3 different cases. All right. Because we have a quadratic and a linear function, one of our graphs is always going to be a parabola, and then the other is going to be a line. Well, there will be one solution if the line just touches the parabola at a single point. There will be 2 solutions if the line goes through the parabola at 2 different points. There will be no solution if the line is in a place where it's never going to cross the parabola. So graphically, those are the 3 things that can happen. You might notice that there is no infinitely many solutions, and that's because a line and a parabola will never be the exact same function. So that gets thrown out in these type of problems. All right, next one, example 4 says, use a graphing calculator to solve this system by graphing. Again, we could do that. These are functions that we can graph by hand, and I'm going to go ahead and do it that way. You're definitely welcome to plug those into a graphing calculator on Desmos and see what happens. But at the same time, I do believe that these are functions that we should know how to graph by hand. All right, the top equation, this is a linear function. Slope is 2, y-intercept is 1. So I'm going to have a point at 1. I'm going to go up to right 1, up to right 1, and down to left 1 to get the graph of this line. Okay. If I look at the other function, it's negative, so it's reflected. The minus 5 is going to move it right 5, and then the minus 2 is going to move it down 2. Well, if I know that this is a parabola that's reflected, right 5 down 2, well, I'm going to go right 5. So 1, 2, 3, 4, 5, and I'm going to go down 2 for my vertex. Over 1, down 1 in both directions. The parabola is going to open like this. What we should see is that this line and this parabola are never going to intersect each other. So when they do not intersect, we answer no solution. Okay. If you had to do that with a graphing calculator, perfectly fine. Not a big deal. All right. Next. So, example 5. This becomes kind of a tricky problem, okay? it says, which of the following systems of equations could a student use to write a quadratic function in standard form of a parabola passing through these points? So the thing to remember is that when you have a when you have a coordinate, there's always an x and a y value. So each one of these represent an x and a y value. A parabola in standard form is ax squared plus bx plus c equals y. Now, I could have put the y on either side I wanted to. I put it over here because that's how these answers are set up. The thing that we need to understand to answer this question is that to write our system or to write our function, we're going to need to know a, b, and c. 3 unknowns means 3 equations. And the way that we're going to come up with those equations is we're going to plug these coordinates into this equation. All right. So if I use the point 1, negative 3, then this becomes a times 1 squared plus b times 1 plus c equals negative 3. If I plug in the second point, it's a times 4 squared plus b times 4 plus c equals 6. And if I plug in the last point, it's a times 5 squared plus b times 5 plus c equals 9. So the coordinates allow me to plug in numbers for x and y. This is the system I'm ultimately looking for. What you should be able to recognize is that the right-hand side, the y's have all been replaced with numbers. So that right there gets rid of a and it gets rid of c. All right. If I were to kind of rewrite this out simplified, which I'm going to do just to show you, this would just be a plus b plus c equals negative 3. This would be 16a plus 4b plus c equals 6. And this would be 25a plus 5b plus c equals 9. So that's the system that I would be looking for, which between b and d, it's definitely d. All right. So if you see a question like that, I know that it looks very complicated, but it really comes down to substitution and being able to plug in the numbers for x and y respectively. All right. The last one here, and this can be a tough question. It says a parabola has x-intercepts of 2 and 6 and goes through the point 8, 4. What other point is on the parabola? All right. Well, really, in order for us to answer this question, we need to come up with the equation of a parabola. And given x-intercepts, we're going to do that in intercept form, where, you might remember this, you might not, but it's that equation where we have y equals a times x minus the root times x minus the root. So if we know that we have an x-intercept at 2, that means that our factor is x minus 2. And if the x-intercept is 6, then the factor is x minus 6. So I can use the x-intercepts to come up with the factors. I still don't know a, all right? That's where this additional coordinate's going to come into play, because this coordinate gives us an x and a y value. So I'm going to be able to find a by plugging 8 and 4 into x and y. So 4 is going to equal a times 8 minus 2 times 8 minus 6. Okay, so 4 went in for y, 8 went in for x. If I work to solve this, 8 minus 2 is 6, 8 minus 6 is 2, so 4 equals 12a. If I divide 4 by 12, that's going to reduce to 1/3. So then what that lets me do is realize that the equation for our parabola is actually 1/3 x minus 2, x minus 6. Okay. Now I know that's a lot of work already. But we're not done. So then what we're going to need to do is basically plug in each x value into this equation until we find the one that gives us the corresponding y value. So if we start with a, so if we were to check a, all right, our equation would be y equals 1/3 times -2 minus 2, -2 minus 6. So this would be 1/3, -4, -8. Well, this is 1/3 of 32. Well, 1/3 of 32 is not -2. It's not a. Okay. B, y equals 1/3. This time we're going to plug in 4. So 4 minus 2, 4 minus 6. This is 2 times -2. Well, 1/3 of -4 is not -2. So that's out. Okay, so you can kind of see there's just a lot of work here. For C, y equals 1/3 of -3 minus 2, -3 minus 6. So this becomes -3 minus 2, which is -5. -3 minus 6 is -9. 1/3 of 45. Well, 1/3 of 45 is 15. 15 is the y coordinate. That is our answer. Because of the amount of work involved in a question like this, once you have your answer, I would not mess with the next number. That's not going to work. C is the correct answer. All right, guys. Hope you found this helpful. If you need help, rewatch the video or talk to your teacher. Have a good day.